So first of all, I would like to say that this is the first public talk for me. So please bear with me. I will try to say things very slow and clean. So our topic is atomic design in React. So who we are? I'm Jason. I'm the product design lead of Iterative, and then Fabio is also Italian developer, who is our senior software engineer. So one of the reasons that we would like to share you our experience is because we have very fresh experience of applying atomic design with React component. In last year, we spent like 9 months to work on Squad to basically refactoring all the UI components from the existing applications. So I hope you enjoyed our sharing. So just to give you a little bit more information about Iterative, Iterative is a retail analysis platform. Our software gathers information to billions of products worldwide. It reads and collects every single bit of information available from the product. When we then use machine learning technology to analyze the information and structure it into categories, colors, price, and performance related activities by teaching the software how to recognize products and interpret the data. So we have over 800 billion data points over the world. We have monitored 90,000 brands. And then, so what we do is we have a huge data base of all the product information, and we would like to help the user to make a better decisions based on data that we collect. So this is an overview of Iterative. And so what we are going to cover today is like, first, I will talk about the reason that we applied atomic design. And then I will talk slightly about the atomic design in practice. So how do we apply atomic design into building a design system for everyone in the team to use. And then Fabio is going to talk about, in the technical side, how do we, based on the component that we create, we then make it happening into React. And finally, we'll talk about the successful story and lessons we learned. Yes. So first of all, why do we choose atomic design? So, well, like there's multiple reasons. One of the reasons is we would like to break the waterfall process. So what it means is like the traditional product cycle is we first have a product owner to do the research, then they will do analysis, and then the designer will do the UI design, they will think about the UX, they will do prototype, and then the engineer will then build it, and then do validation, do testing, and release it. The problem of it is like the fact that most of the front-end developers have strong opinion, and it just killed them that they have little impaction on the design. And basically, by working as a waterfall process, it's very difficult to iterate any design changes at the later stage, which we would like to avoid. So instead of a waterfall process, we would like to have an iterative design cycle. So what I mean is like, so it's similar. At the beginning, we have product owner to do research, but slightly differently, we will have a cycle, a loop in the middle. So what I mean is like, we will do analysis, we will do design, we will have developer build it, we will validate the same, but then we'll iterate the process until we are happy with the design. Because a lot of the time it's like if we do design in a very top level and then we don't iterate it, like one of the audience said before, like it's so difficult to consider all the situations and how it looks like from bottom to top. Also, we then have more perspective from different people from the team. Like everyone could join the idea generation sections. Everyone can give their opinions, and that makes everyone in the team much more happier. In order to create a future-proof design, so this is the history of edited app. Edited app is being built for like 9 years, and then on the left-hand side is the design 8 to 9 years ago, and in the middle is like 3 years ago, and then on the right-hand side is what we just built from last year. So. As you can see, the digital product is getting more complicated from years to years. It visually looks more complicated because users always have new features that they want to add. We want to add more value to the user. We want to add more value to everyone. So you can, okay. So instead of revamping the application every few years, because like revamping the application is like, it takes a lot of energy from everyone from the team. Basically, it takes at least a year to revamp everything. So it doesn't make sense to do it a few years. It's just a waste of time. So therefore, we are looking for a sustainable design system that could be a base, and for now, and also for future, for any other like future iterative design changes. So one of the issues that we have is the app itself is very complicated, that we have over 20, 30 different templates across different sections. They are chart, report, text descriptions, product image, product card, everything that you could think of. But the problem is, it's very difficult to make all the design consistent, because the more people work in the team, the more engineers join the team, the slightly different technology they're using or the way they code it, we just make it more and more complicated after a few months and so on. And so in the current application, the problem that we're facing is that it's very difficult to reuse any element, and no one really know what is the final result or like what to be expect, and don't even know like who to talk to, because one element could be done by one of the developer, but none of the other developers know where to find the code, how to implement it, and or like how many override styles happened. So the last reason is that we want to build a reusable component library that basically acts as a common language for both designer, developer, for people who have no design background, but still easy enough to understand the design system that we have been building. Because basically it's impossible for only designer to make sure design is consistent across the app. We need everyone to understand the design system, including developer, including product manager, including everyone. By having online, okay, yes, sorry. So how could we approach atomic design? So this slide is basically the same as before, so I'm not going to talk about it again. But then what is interesting is that this is an example of our retail report. So yes, as you can see in the pages, it's in the top level design, you see all the elements for the product card. And one of the very interesting things is like one of the audience just asked, like, how do we make design properly? Because like if you design it from bottom to top, it's so easy to make design look shit in top level. Because when think about it, when you're looking at bottom level, the most basic element, if you're just looking at it, it's so easy to make a design decision over it. But then you don't know the relationship between this component to other component, and thus it makes it difficult to imagine the overall outcome. So that's why some of the design could look pretty shit. But I do have to say, like, the way we do design is not just from bottom to top. In the beginning, we spent like 1 month of time, each designer just try to revamp the existing page with everything on the design, and try to redesign every component. And then we just literally just talk together and like change the design, change everything until a stage that we are quite happy of what we have. Then we start build the atomic component, the molecule component, and organism component, because that at least we try to figure out how it looks like in top level. And then, so I'm not going to go through the atom designed element to details. The one thing that we apply in automated design is not just component, not just text box. It could also about the color of the font size, of the font. Could be about the font size, the scales, and also could be a system like, for example, we are using a 3-pixel grid system. What it means is like every margin padding in all the components should be a number of multiple by 3. And like those rules is just helping to make a more consistent UI. So if you combine a few atom components together, it will be a molecule. And then you combine a few molecule and atom together, you will get a self-contained organisms, which is a polycard. And on the left is a feature polycard. On the middle is default. And on the right is like when you hover it, you see more information. So eventually, we built a page with the header, with a global search, with everything. One of the reasons that we apply atomic design is because by creating the structure from bottom to top, it's basically the same. We're building the same vocabulary for developer. Developer can also build all the component as in the same structure. So it's so easy for designer and developer to understand each other. And it's also easier to like make component more consistent for the application. But then, so far what I'm showing you is just a style guide for designer. So what's next? So how could we make it available for everyone? Because what we're looking at is more like a designer perspective. So we need a single source of truth. Like a pattern library, or some people call online style guide. So basically, it's style guide that unified experience for designer and developer. It's not just for designer to follow, but also for developer, product manager, and data scientists to understand it. So for us to build the online style guide, the most important thing is to make sure the developer are happy with it and they can use it. So this is the living design system that we have currently. As you can see on the left-hand side, there's getting started. So basically, it's a page to talk about how do you start using the style guide as a designer and as a developer. You can see what library we're using, like how to build it from GitHub. And then you'll see there's a style on the slightly below to getting started. So basically style is like the basic rules for everything, like the color that we are using, the grid system, the typography, the text scale, that could apply to all the components. Basically like nature rules. And then we have components, which is we don't define it into atom component, molecule component, organism component. We just make it component, very simple, reusable component, like input box, like button, like track box, radio button. We do have something called widget, which is slightly more complicated, like a polycard, with a few atom elements combined together. And on the right-hand side, you see the specification of that element. You also see the code example and how it visually looks like. As in a button, and you can hover it and play with it. And one thing that we are quite interesting is that we use free background. We basically create all the components based on free background color, which is white background, and dark background, basically for trying to cater the future use. Because this 3 color is the only background color that we are using. And as you can see, the button and the component visual will be varies based on different background colors. And we also have icon library that anyone can go and just export SVG and PNG. We have a motion guide to talk about the motion behavior across all the components. This is interesting. So imagine on-style guy have more and more engineer working on. The problem is it's very difficult to maintain the version of each component. So we will have a component status to talk about like each component. Are they most updated? Are they being like ratings for review? And yes, of course, we have to make it developer friendly. So that they can easily use it. And I think that's all from me. I should pass it to Fabio to talk about how do we apply it in React component.
I'm Fabio, I'm a JavaScript developer. So how do we use the content that JSON and design team gave us to create some new components that we can use and reuse into our app? When the design team gives us some new content, it comes into the format of a Figma file. We can access this through our browser, and we get to see this example. We get an example where you can see every single state in which a component is going to find itself into, and all the inputs that this component will accept. So in this case, I use the example of a checkbox because it's quite a functional element. It takes a function, has some input, has a lot of states actually. So I want to develop this. What do I do first? The first thing I will always do is decide on an API. So let's make a very simple API. We call this design-driven API. We decided that the best way to make generic components that are as similar as the designers want is to make sure our API only does what designers want the component to do. This means we get a one-on-one situation between our code and the design. As you can see here, you got a theme, which is what Jason was talking about earlier, that we have components that are available on different backgrounds. You get a check prop, you get indeterminate, which is that dash version of the checkbox. You will know all the others: disable, hover, focus for accessibility, and the function on change when you click the button, the checkbox, and a label, which is the only input in this case that is displayed to the user. So let's make this example. I have to create a checkbox that has to be displayed with a check, with a tick, and this label, which is a tick checked. You will straight away find that we have in our props all the items that we need to fill in. So as I said, it's very, very important that we keep this API as simple as possible, as generic as possible. You can see that this API is it gives out that this component is stateless. In fact, we have hovered and focused external through a prop. It's the parent that decides whether a checkbox is clicked or is checked, whether it's focused. And for us, it's very important that these props are extremely strict. We want the props to be as few as possible. Try to use primitive variables. And if you really, really have to pass an object, do use the shape check. So we only want to allow keys that are allowed into this component. This is because we don't want the component to change in unexpected ways, especially when you use style. I know many will pass a style down to a component, and this is actually quite common, and we don't really like to do that, because that means that a parent that uses this component may decide to do absolutely anything with the design of this checkbox. In fact, while I make this example, this is also an example to say, do not use style with the atomic design. The parent doesn't know what it's using, and the design of this component shouldn't be attacked by anybody. So you have to use this design as the only source of truth to make your component. You shouldn't look where this component is used. This is not your business. Your business is making this component and make so there is no unexpected situation that may come from using the API. And to make very sure that this happens is you're always going to write some tests. We use Jest and we use Enzyme. It's very easy to write meaningful tests with atomic design components because since you don't really know what's the parent, you will write some components which don't have any dependency across on the upper side, and that's very important because that means that API, the components are going to respond in a single way to the props you're going to pass into them. As you can see here, we have this line where we talk about snapshots. In fact, we do snapshots on our components. We do shallow snapshots on our components. A snapshot is kind of a carbon copy, an output that you can get from the component. And we store this in our repository because that's what we expect the component to print into our web page. Whenever you run test, we check against this to make sure the component didn't change unexpectedly. And this is just one extra way to check whether our component behaves as we want in a single way. So whenever you run the test, if you change the component, the test is going to, besides giving an error, it's going to display which line changed. And that's extremely important for us to understand, an example, how the CSS has changed across versions. It's very good to have atomic design in this case because you can do very reliable shallow testing, which many disagree with, but this is because usually it's much better to have deep snapshots that snapshot the entire tree of the HTML, but it's extremely expensive in time and it's very slow for developers when they are developing something new. So atomic design allows to snapshot a single component, a very thin layer, and you are sure you're only working on that. A very good after effect of using atomic design was that since the designers are maintaining the components with the same name and same scope as developers, you will find yourself that designers won't really drop their components. They won't change the scope of their components, which means there's going to be less test overhauls. You will not throw your test away. You will keep them for pretty much as long as you're going to have your component until it gets deprecated. So we got some new components now. Let's use them in action. We organize our components in this way. We create a component library. We put into this component library components which are extremely generic, reusable, and we put them into 3 directories mainly. One is items, one is molecules, and one is organism. We talked about it earlier. These are components which have very simple APIs again. They don't take any complex data structure. They don't get any Redux in them. You can use them with any framework whatsoever you wanted. And you could also use them without any framework, basically. And then we split these components between component library and application. In the application, you put the more specific stuff. There you will put the organisms that take much more data. It's very likely that you will have some organisms that just take the whole state from Redux or whatever library you use for storage. And you will have some pages, and we use these pages that we talked about earlier, kind of like modules. We put into the pages, let's say we make a dashboard page, which is like the first part where the app when you open the app, you reach the dashboard, and this is kind of like a module inside, and inside you're going to also find your Redux reducers. And then we'll have charts, and there's going to be much more pages in this area. One more thing that happens after you design a component library is how the designers are going to be willing to create even more components. It is very likely that you and the designers are going to start bickering about the components because the developers don't want to write more components. We are lazy. And the designers have quite an easier time creating more components. So you'll end up in this kind of passive-aggressive situation where you want the designers to do more work and you want to do less work. And what happens is that we are very friendly in Edited, so nothing like that really happens. And so what happens is that very often we go to the design team and we tell them, look, these 2 components do the exact same thing. Why do you make a new one? And they realize they actually made a new one for no reason. So we go back and use the same component we already had in our component library. And very often it's just like a trade-off. We just prefer reusing an old component that we already have. It's not like 100% perfect for our interface, but it's much cheaper to just implement without recreating a new one, which is like perfection. Perfection is not a thing anyway. Another good way to use our atomic design component library is with MVPs. MVPs are a major thing for us. We make a lot of features and they are very, very complex. And we want to make sure we don't create features that are not useful for our customers. It's very expensive to make a feature. It can take months. So what we do is making sure the designers don't do more work than they need to do. And what happens is, as you can see on the left side, we have a design. Probably for you guys, this won't mean much, the design. But for us, who have the component library, we can recognize each part of that design and make it real without a full high-quality design from the designers. So as you can see, this part on the right has been made from the part of the left. There was never a full design of this. These are made by front-end developers on a component library. We saved so much time on that. We managed to bring on photo of the customer success team a full product in a matter of days, and they were able to just use it and say, well, this is great, let's go with it. And now we're making a full design for this. So how is atomic design working for us? Okay, almost done. So we now are able to do quicker iterations. We are able to, the designers just ask for changes. They just go on our GitHub, they make a new issue, they make some screenshots, and that way we are able to make updates to the designs without any issue. Everything is very independent, it's its own thing, so we can release it separately. And these changes happen way across all the interfaces, and all the tests and snapshots are unique for the test, and only this change whenever you make a release, so you don't really need to go and change test across all the code base. And finally, we have this ability to just QA the component we created or change it, instead of testing the whole page, an example, which would happen before because we wouldn't trust our components. This made the onboarding much easier. That's a boat, that's me on the boat, and it's edited on the boat, so this is onboarding. Onboarding has been made extremely easy because these components are they don't really have a context. You don't need context to use these components. You just take them from the component library. They're independent. They don't have any side effects. You just drop them into any interface and they work. As long as nothing really tries to change their style, it just works. And we had this new developer called Jan. He joined the day of a hack day. And by the end of the hack day, he was able to make a full interface. So in less than 8 hours, he was able to master our component library. And we have a consistent experience everywhere. This image is from a backend developer. Backend developers in Edited, some have some experience with React, very minimal, but they were able to create a very complex interface made for monitoring our backend with our components library, and it's slick. It's very good to use, and it's very fast. And there was no designer involved. He just made it, which was a huge time saver. So lessons we learned, finally. We learned that you should, before you start doing this kind of migration and like refactoring all your code base, do upgrade your libraries because it's much harder to do it later. Yeah. And go depth first, start from a page, create all the components for that page, then move on to the next one. Don't try to make 10 pages at the same time and all the atoms for it. You're gonna lose yourself. Just start simple and make some atoms. The second page you make, you will have already some atoms done and some experience using atomic design. It's gonna be so much easier. Don't, again, for the 10th time maybe, don't handle too complex data in the library components. And develop components even if the level of confidence is low. It's an iterative process. You shouldn't really worry too much about how perfect is the component as soon as you create it. Just created. Even if the design changes after the first iteration, it's just CSS most likely. If you did some accessibility work, if you did some logic work, it's going to stick. This is usually not the case that it will change massively on the logic side. So here we are. This is almost over. We will put our slides on our website, most likely on edited.tech, and on the page of the meetup. Edited.tech contains some information about our company, what we do with our data. And thank you very much. I'll just remind you that we are hiring across all our stack, and you can find some leaflets over there. And that's it.